Okay, example 2, and I didn't write example 2 up here, but let me do that real quick, just in case you need it. Alright, so example 2, directions again are to use Gaussian elimination to solve the following system. So let's stop real quick and let's go ahead and let's write our augmented matrix. Alright, so once again, just like we did before, because it's Gaussian elimination, we want the diagonal with 1s, and all the numbers to the left of it, or kind of below it, need to be 0s. So of course we start out where we want this to be a 1. It is, so we're good there. So let's move on. Then we want this to be a 0. How can I make that become a 0? Well, I need a negative 2 so I can add it to it. So I'm going to take row 1, I'm going to multiply it by negative 2 and add row 2 to it. Now this time, instead of just working out with you, I want you to pause the video and I want you to do this one on your own. See if you can get that one right. Some of y'all may have already been doing that. Some of y'all may not have been. So pause the video and try it, and I'm going to pause it and put the answer up there. Okay, so check it. If you need to, stop and pause it. I showed my work at the bottom and see what I did to see what you got different possibly. Okay, so now we got the 1 in the first row. We got the 0 in the second row, so we need a 0 right here. What can I do there that would give me a 0? Well, if I combined it with a negative 1, that would work. So what if I just took row 3 and I subtract row 1, but I put it back in row 1? Remember, it's kind of like the other one that we did, and we had to write it a little different. So I'm going to take, what did I say, row 3, I don't remember how I worded it now, row 3, and I subtract row 1, and I'm going to put that back in row 3. I may have said it backwards earlier. I can't swear to it. But that's what we need to do there. Alright, so again, I want you to stop and pause the video, and I want you to try this one. Okay, so check. Remember, your row 1 and row 2 didn't change. You should only have to look at row 3 unless you made some changes on the others. Alright, so we got our 1, 0, 0 in our first column. Now we need this right here to be a 1. So how are we going to make that become a positive 1? Well, it's already a negative 1, so what if I just multiplied that entire row by negative 1? So let's do that. So we're going to do negative 1 times R2. So again, and that's going to be my R2. So again, let's pause the video and try that one. Okay, so check it again. Row 2 should have been the only one that changed this time. So just look at it. The other 2 rows should have stayed the same. So, alright, so check it. If it's different, all I did was I multiplied everything in row 2 by negative 1. So I didn't actually write out my work on this one, because when you multiply by negative 1, all it does is change the signs. Alright, so now we're down to, we need that number right there to be a 0. How can I make it a 0? But be careful, because of that 0 in front of it, I can't do anything that's going to make that change. So I need to, if I'm going to add or subtract, I need to do it with a row that has a 0 there already. So I'm going to have to combine row 2 and row 3 somehow to get that. Well, to make that a 0. So what if I just went ahead and added them? Because row 2 is a positive 1 there, and row 3 is a negative 1. If I add them, I get 0. So we're going to take, for our next part, we're going to take row 2 plus row 3, and we're going to let that be our new row 3. So one more time at least, let's go ahead and pause the video and work on that. Okay. So, showed my combining here. Again, I'm alerted because I see a whole bunch of zeros in that bottom row. So remember, this part here tells me there's something different going on, and so we have to look at that. So when I look at that third row, that tells me then that 0x plus 0y plus 0z equals 0. Well, this is the same as what we had on the previous example, so we know that's going to equal 0 equals 0. Is that true? Yes, 0 is equal to 0. So because it's true, that means that that equation is dependent on the others. So I can rewrite my augmented matrix without that equation or without that row. So we can rewrite it as 1, negative 2, negative 1, my line, and a 5, and then 0, 1, negative 5, and 4. Now, because that's true, that means that z is going to be equal to z. Okay, so that means I'm going to have a variable in all my answers. I'm not going to come out with nice, neat answers like I did on the other examples in 6.1. So let's look at that then. Okay, so I stopped and erased, so we had some room to work. So what that first equation here is telling me is that if I have x minus 2y minus z equals 5. And the second equation there is telling me that y minus 5z equals 4. And we just said because the third one canceled out, that meant z was equal to z. Well, just kind of like before, we're going to go and plug it in backwards. We know z is z, so I have no change to make on this equation right here when I go this way. But I couldn't solve for y, so I'm going to add the 5z, and we get y equals 5z plus 4. And it looks like our curriculum is very specific, guys. It wants you to put the z at the front. Even if its coefficient is negative, it wants it first. Alright, well then if I know y, I can plug it into the previous one over here to solve for x then. So we have x minus 2, we know y is 5z plus 4, minus z is just z, we said that over there on the right, is equal to 5. Now I need to work this out and get x by itself. So again, let's distribute. So we get x minus 10z plus 4, oops, almost didn't distribute there, so plus, nope, minus 8, and then bring down your minus z equals 5. So I'm going to combine my z's, so x minus 11z minus 8 equals 5. Now I'm going to move everything over. So I get x equals the negative 11z, I'm going to add it, so I get positive 11z, add the 8 to the 5, and we get 13. So there's our solution set. We know our x is 11z plus 13, comma, my y is 5z plus 4, comma, and we know z is just z. And so there's our answer.